Just find the right place in the program, make the appropriate change, and we'll run the whole thing again. Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. The art of leadership is delegation.
That information is not available. This constitutes all available data.
You know what they say, no good deed goes unpunished.
Hello, morning. No, it's not morning, afternoon, evening. It's evening. Who knows? Who cares? Andreas is on this repeater. Yeah, he's on here. GB3CR. Must be talking YAESU or something, I don't know. Yeah, I'll listen to him.
Oh, thanks, Ken. Yeah, just testing my nose really, and I do like the clear, transparent transceivers. This one does airbag. Just been listening to a plane fly over my head. I'll talk a bit closer.
Yeah,
it flew over my head.
Good going.
Talk a bit closer.
Anyway,
Here listening to the Spanish pilot.
Spanish pilot.
Back to you.
Jesus.
Back to you.
I've never heard him on the radio before. That's funny. Anyway, so what are we doing today? We've got the meters working. So I want to get rid of this stuff here if I can. Get rid of this stuff, which means I've got to put that button on the fast button up here. So when you click, make this automatically do everything without clicking. And I've gone ahead and made the meters swap over. So this space is available. All this space here is available. Let's make sure we've got some audio. Hang on. Yeah. So this place is available when you're receiving. When you're transmitting, we replace it, the signal strength, with all the meters. Don't know what all these meters are. Which is power and SWR, and your compression, and your auto level control. Yeah, all that makes sense. Don't know what that one is. Anyway.
M7FTJ, Andreas, you play this one?
Oh, they're all having to talk to him now.
Yeah, Roger. Still here making a snack before I close down. Back to you.
Andreas. Anyway, right, so let's get on with it then. So what I'm going to do today, with meters are done, so what I'm going to do is I quite fancy a nice, intelligent frequency scan. So you scan the frequency. If it finds anything over a certain signal strength, it will... Now first it'll do a first sweep of the band and find out the mean value of the signal strength of the noise level. Then it'll, on the next go, it will look at the, or maybe on the first sweep, it'll determine what the signal floor, the noise level is, or the ambient, let's call it ambient signal strength. And then it'll determine if there's any noise, or it can't tell if it's a voice or anything like that. It can tell if the signal strength raises. That's all it can tell. It's not feeding audio into a sound card or anything. So we look at signal strengths, and it's going to remember those signal strengths. So it's going to put those signal strength, those frequencies into a dictionary, and remember, it's like a list. Put it into a list, and then once the list is generated, it comes to the end of the band. The list will then contain anything with a signal strength so much and above, and then it'll just go. It'll have a dwell time. It'll go to the first one in the list, and then just go through the list, cycling. Spend so many seconds. If it sees the signal strength on that one is just down at the ambient, like there was a signal but it's gone, after 5 seconds it'll just, so many seconds it'll just skip on. And if it sees a strong signal strength, it can dwell there longer. So you can do all the kind of stuff with it. So what I want to do is make this useful. I don't know if you can do it on the normal radio. You might be able to, but anyway, because we've got the cat control, we can measure the signal strength, we can change the channel very quickly, we can do stuff we can't normally do. So I'm going to, maybe you can get a tool that already does it, probably, but I don't know. Anyway, let's crack on with it. So right, let's get this over here. So we're on the old program here. If I run this up now, let's just see what we got. So yeah, I've got to create a dispatch timer and get rid of this me having to start it. That's just showing you the default. So if I click that, it goes to S. I've got it fully up at the minute, so if I knock that off. So I pick the mic up, let's just find the frequency, that'll do. And I'll just pipe up, here we go. G7UIV, test only. G7UIV, test only. So it swaps the meters around. I'll do it again in case anyone missed it. Golf 7, Uniform India Victor, just test only, testing 1, 2, 3, test out. Right, anyway. So you've got your screen real estate. Your real estate is back when you're receiving. When you transmit, it takes over that meter, because that meter does nothing anyway when you're transmitting, as far as I know. Okay. So basically, by setting your meter on your radio, you're just swapping out what the signal strength does. That's basically what you do when you transmit. But instead of swapping out one, we've got all of them available. Show you again. G7UIV testing only. G7UIV testing only. So you've got the whole lot there, right? Anyway, so that's done. So we'll leave that alone. So now we've got to create a list, a new class. It's a new class, so let's put this. Let's get that up out of the way, like that. Okay, let's stop that. So, now I want it. I can either create the class now, or sort out the. I tell you what. Let's sort out the dispatch timer. So at the minute we're doing. We're having to run this docat command. So we're running a docat, and then we're in a for next loop. We're counting up to 10,000, and then we're starting again. Well, we stop. So you have to keep clicking, do it again. So, and what I've done is I have to put in the function. It only requests the comp, the ALC, the PO, and the SWR and the IDD if the radio is actually in transmitting. Otherwise, it'll only ask for the S meter. It asks for the S meter. It gets the transmit state, So that'll ask for the state, and that directly changes the state here from radio's TXing or is not TXing, which is receiving. If it's TXing, it'll then ask for these, and it won't ask for the S meter, and vice versa. And the only other thing it asks for is the frequency. Now it does ask for that quite a lot of times every second, even though you're not changing. So we've got no real control here. We'll just do it. The only control we've got is this await task delay of 10 milliseconds. So it's a delay in milliseconds, 10. So we're having to put this delay there, and if we do it in a proper way, we won't have to do that. We'll have a dispatch timer. So instead of trying to reinvent the wheel, I'll open up again I'll open up another instance of Visual Studio, and I'll open up my main UPass project, because in there I've got a nice dispatch timer. So I'll just copy the code from that. So I'm going to close some of this down. I'll leave that there. So what we're going to do is have a look at the top of here, and there'll be something reference to a dispatch timer. Let's have a look down it. I think it's in the RGU serial packet module. I think it is in. Let's just double check. Just make sure it isn't down here. No, I think it's in. Well, let's go over to forms, and we've got packets, engine packets form. I can't remember if it's in there or it's, I don't know where it is. It's been a while. Let's try and find it. Let's first look in. Makes sense to have it in the packets, engine packets form. So I'll have a look in here. Dispatch timer, there it is. Engine packets, because this actually does all the servicing. So the dispatch timer, yeah, here it is. It's all here. Look. Every time a packet gets sent out, it has to talk to it. Show engine packets. So show serial port packets. We've got various types of multicast packets. Yeah, so this will be it. So we're only dealing at the minute with packet for serial port. Okay, so what I'm going to do is I'm going to create a dispatch timer. I'm going to copy that. I'm going to put that in routine. Now, because we've only got a radio working here, we don't have too much going on. We haven't got a dedicated class for the serial yet. It's all on here at the minute. So we'll just put the dispatch timer here, and we're going to call it. It's not a packet really. I suppose it is a packet. Serial packet. It is a packet. It's sending some kind of data back and forth. So we'll call it a serial port packet. Serial port packets dispatch timer. That'll do. Okay. So what we want is we need to initialize the timer. That's just the variable. So here's the dispatch timer. You got milliseconds, right? So so we're going to just copy this here, and we can start the timer and stop the timer. When you close down the form, it will stop the timer and make the dispatch timer to null. So we need to do that as well, really, because it could run on it if carry on running. So we need to start the dispatch timer. We can do it in the initial startup. We don't need async anymore. Yeah, we don't need async because we only have async when we only have async when right, so we need to swap that out. Gonna renaming that. We only need async when we're trying to because we're having a dispatch time. We don't need it. Right, tick value. I'm just going to make it 1,000 for now. That's how many times the dispatch timer executes or event gets triggered. Right. Okay, and then we've got the closing down and the null. So, but we need this engine dispatch timer tick, so we need to find that. Go to definition. Here it is. So there's the event that executes, and it's doing some housekeeping. We only need that function there. Okay, so we're going to put it right down here, just after startup, so we know where it is and we know what we're going to include in it. Right, okay. So, and we're not going to call it, we're going to call it serial port packets, or a packet of cornflakes. And that's it. Right, so we've told it to start. Now what we need to form closing. We need a form. Let me just go back to that other one a minute. So we need a form closing. So you got your dispatch. Yeah, so that initializes it in there and closing down. So we're going to have a look over here. We're going to have to find the metro loaded closing. Yeah, so we need to put this. I think we'll have a window loaded as well. So we won't do anything till our window is loaded. Alright, so we're going to put that in there. Let's do that now. Do it properly. So I normally put events at the end of the declaration. Right. So metro window loaded. Metro. That's okay. So we'll do a go to definition. That'll create a new one. And then we'll do a closing and go to definition. But we're going to move these now at the top. Put some at the bottom of the list. We're going to put them at the top so we can see them. And I can put them there. Tell you what, I'll just put them underneath here. That's it. Alright, so we've got our dispatch time. We've got everything we need right close there. Okay, so when we want to turn the timer off when we're closing it. So to do that, we're gonna metro loaded. So this is all the initialization stuff for the UI. We'll wait for the UI to open up and then we'll issue a command. So we'll do that. So let's just go back here and closing, go to the definition, metro closing. Oh, we're in the wrong, I'm in the wrong thing here, sorry. Oh, am I? Yeah, I'm in the wrong thing. I need to be in this one. Yeah, there it is. engine packets list. So this shuts all the lists down as well. Just make them null and actually close it. Yeah. Right, so I'm going to have to get back over to my one now. So for the closing, obviously we're just going to take that out for a minute. And we need the name of the real name. So we'll just swap that out. So when we close the program, it shuts down the timer and closes it. So when we're loaded, we can do stuff like initialize this. So yeah, we can start the timer when we're loaded. So I'll move all that into the window loaded. Okay. So the window loaded gets done after initialize components. Normally, I think. Right, so serial port packet dispatch timer. So this is just something we do at startup. We don't need to do that really. Let's just stop that. We don't need to do that at the minute. Right, so we're going to do that. So we've got our loaded and closing. That's okay. So once we're loaded, we can initialize our startup. I'll tell you what, we'll put it here. Hang on, there's some stuff we need to do here. Yeah. Like open the port. That can stay there. Right, this can be moved out of here now. We'll put that in the loaded. Yeah, let's put that in there. Actually, I'll tell you what we'll do. Where do we put that? Yeah, we'll actually put it in here. We'll put it in here, and we'll bring this one back, and we'll move that start up to loaded. So it needs to do as soon as it's loaded, it needs to initialize the startup really, and that could just stay as it is like that. That's fine. And this, it'll get executed as soon as the window's finished loading, and then it'll initialize the startup and start the dispatch timer. Okay, so that looks after that, so that's great. Initial startup, right, okay, that can stay where it is. Yeah, so what we're going to see if that all works again. Now, hopefully, if we move our where is that gone? Do cat command. So we want all this. We don't need the for next loop anymore. So we want to take all this. If he's dragging, right? Okay. So we want some of this. This is our main cycle. Alright, so I'm going to move this up to dispatch timer. This is what gets executed every cycle. We don't need no await delay now. Actually, probably we would do. Because it's going to try and execute all them in one go still. Right, I'm going to have a look at that. I'll have to have a look at that. So while he's dragging, we don't need the 4 next loop. Let's get rid of the 4 next loop. Right, and we don't need the run anymore. Don't need that anymore. What we need now. So the dispatch timer. We need we need to do one of these things every time it dispatches. Not all of them every time. So we're going to have to do keep a bit of a track here. So right. Okay, it's going to have to be a value here. Let's just create something. What we're going to call it? Yeah, how did I do it last time? Yeah, I did something crazy last time. Yeah, because you don't want it to dish. So show engine packets. Now it was service in the packets. I don't know where that bit is. Engine dispatch, show engine packets. No, it's not in this bit. Where would it be? Engine packets. Now we've got another packets. Serial port management. Right, I thought it was here, but no, there's one called service. I'll have to look in the main one to find that. What I did is every time it went into an iteration, it would increment something to the next instruction. I don't know where it is now. I can't remember. Yeah, it services an engine at a time, basically. So the dispatch timer. Yeah, you can never find it when you want it, can you? Right. Show multicast packets. It's not here. I've got a lot of files to look through, so it's finding them. How are the coding going? How you doing, Andy? Oh, you've got a big crown and a blue thing today. Let's have a look. Yeah, it's going alright. I'll show you in a minute. Let me show you. Let's get back to this. Alright. I've broken the code at the minute. But I could show you there. Here you are. If this will run, yeah. This is the last one. We've got this now. This is actually broken on this one, so great day. Oh yeah. Right, so we've got this. And I've got it to G7UIV testing only. G7UIV testing only. So it goes, switches all the meters on and switches them off. G7UIV test only. Anyway, so we've got that. So what I'm doing now is sorting the dispatch timer out. Let me just close that one off. So it's sorting out the dispatch timer. So we've got to do that, and so I need to increment something. So let's tracking. We only want it in every time the dispatch timer triggers. It's basically a timer that triggers every whatever. I've set it for one. Every, where has it gone? Here somewhere. Yeah, every 1000 milliseconds. Every second. That's going to be too slow. Let's just change it to, I don't know, let's say 50 milliseconds. Every 50 milliseconds, this function here is going to get called. Now, we don't want it to, once I take these awaiting task delay out, it's going to want to try and do all these in one go. We don't want that. We need a pause between the two, between each one. So what we're going to do is put it in a bit of a thing that looking for an increment number. So I'm going to make this one. So I'm going to be what do I call it? Just trying to find a name for it. Yeah, so I'm going to increment it. I don't know. Serial port packet. I'll just say next serial port packet, because they are packets. Right, so I'm going to just leave that one as default 0. So basically I'm going to increment that every time it goes to the bottom of the list. I'll just do a ++ on it. So basically it'll just increment it. So all we've got to do is say so we're going to decide what we're going to do on every pass. Alright, transmit state, that's quite important. Well, if we poll it quick enough, I think we could probably just set that for less than that. We could probably just do it every 10 milliseconds, because that was the pause time we had built into it here. Await task 10 milliseconds. So I think we can do it every 10 milliseconds. Acid cows. Hey, interesting. I found this. I've been working on a new front end for the 891 as well. Oh, very good. That's mad, isn't it? Everyone. Yeah, that's brilliant. Yeah. Yeah, let me just welcome you to the live stream. It's amazing, isn't it? Yeah, you could probably get there's tools you can get that does all this all for you, but it's just a learning curve basically. I said I'd always welcome everyone new to the live stream, so there you go. Yeah. Oh yeah, I wonder what you're writing. What are you writing it in? Are you using? What are you using? I know Stuart with the station master is using. Is it Rust or something he was using? Trying to build something that will use a touch screen off a Raspberry Pi. Oh, fair play. Yeah. Well, yeah, you could use touch screens. Are easy to do. Touch screen stuff's dead easy. You just need the driver for it. Using Go for now. Go. Oh, I don't know what Go is. I've no idea what Go is. I write in C Arduino Core C++ style. Desktop C# and Windows Presentation Foundation. That's what I use. So I don't. Some of these languages I don't know what they are. I don't use Python. A lot of people use Python. I don't use Python. I like a more structured thing with the. I suppose Python. I've just never needed it any. I've got Arduinos, I've got ESP32s, I've got Pi Picos, but I've got Raspberry Pis, but I've never actually done. I've got loads of Raspberry Pi. I've never done anything with them. I've always managed to do what I want to do with ESP32, Arduino, and stuff like that. I don't need the power of some of the Raspberry Pi. I'm not able to wrap my head around the Windows stuff, lol. Yeah. I've been Yeah, I've been programming Windows for a long time, but I'm not an Apple person. I don't know nothing about apples, apart from they grow on trees. Yeah, yeah. Sorry. Yeah, the Windows stuff. There's loads of frameworks. Absolutely tons of frameworks. The one I'm using is old now. It's old, but it's still useful. But it's old. If you want to keep, you've got to try and move with the times. I'm also not a great fan of Python. When I need a quick, dirty script, sometimes I'll dig it out. But managing the environment, having to have it installed on every machine, I can do whatever I want with Arduino Core. C, a derivative of C++, C, whatever you want to call it. I can do everything I want with that. I've never found a problem, and it's dead easy to write in. So I don't know why people want to go to. I don't know. I mean, it's yes. I don't know. I think it's the fact that you can do it on the fly, edit stuff. But I don't get it. I never understand. I know Unexpected Maker, he uses Python sometimes, and I query him. I go, why are you using Python? Why do you use C sharp? I don't know. Never mind. You don't have to use all the fancy C stuff, all the fancy black art stuff in the language. You don't have to use that. You can just make it as simple as you want. But anyway, yeah, welcome to the stream. Anyway, nice to see how far you've got. I mean, I only started this a few days ago. What I'm doing here, I just started a few days ago, and I bought this 891, and I'm thinking, let's see what we can do, because I've got other radios and the stuff is accessible. You know, I've got 710. That's pretty good. I don't really need to do much with it externally, but you probably could do. And I've got this 510 for VHF, UHF. Now this one's brilliant. It's okay. The little 891's nice. I'm trying to learn these more lower level stuff. Spent the last 5 years working in distributed system stuff, so programming ESP has been a big shift, but I really appreciate it. Yeah. Yeah, I mean, I've wrote my own website, I've done all that kind of stuff, and I've embedded, I've made ESP32 controllers, which I use. And I've wrote my own firmware for it to host its own web interface. That's what I'm using on the rotator. So it doesn't need any cloud services. It's probably still running there. I think it's still plugged in. It is still plugged in here. I'll show you. Let's show you. Excuse the mess. I got projects everywhere. Right. So if I just go onto my phone, just type in my wire. Right, there it is. So there's my web interface. Oh, there it is. So you log in, and then you can click a relay. Now this is hosting its own web interface. And there's the gadget. Oops. Oh, go away. There's my ESP32 controller with its web interface, and you can access it anywhere in the world. At this point, you could go on it if you want. Have a play. It's upas.mywire.org:81. So it's on port 81. You can have multiple of these in your same building. So that's on there, and that gives you. The idea is to make an antenna switch, so you can switch your antenna. And this is quick. It's dead quick. It's not relying on anyone's service. Anyway, I'll log out. And you can set all your network settings, everything. Well, I'll shut that down. Anyway, going back onto the desktop, so if I opened up... here we go. A super... Nice you have dug into the... Now, I started doing all my programming 14 years ago, 15 years ago, and nobody ever heard of Meshtastic. So, yeah. And I don't use the ESP protocol, I use my own protocol. Why is this not finding it? Hang on. MyWire. Oh, sorry. ups.mywire.org 81. Yeah, there it is. So I've just got that thing behind me. And you can have a full size, it's hosting its own web interface. And you can click a relay. Got 3 relays, and you got switch. This is the experimental bit I've added to it. And even antenna rotator. Anyway, that's the address if anyone have a play. I'll leave it on. You can't do any damage. It's just a standalone hosts its own web interface. That's super neat. Where do you get your ESP boards? Believe it or not, I make them myself. Yeah, I make them myself. Let's find you something. There it is. There's my ESP board. You can't see it. Yeah, I designed the board and made it myself. And this board, you buy this module, it's a plug-in module. It supports a Lalin TFT touchscreen. It's got a stemmer I2C connector as well, and a touchscreen TFT display ports. It's got buzzer, sounder, relay, opto-isolated inputs. What else has it got? A WeGand interface for RFID readers. So anyway, and if you like stuff like that, you'll love the next one. Here we go. You ready for this? Wow, do you use PCB way? No, I don't. I use JLC PCB. I have used PCB way in the past on some of the early projects, but I just use JLC PCB. Here's my welcome to my main project. Here it is. And that unit's on over there, so ignore that. Well, this is Windows presentation for same program I'm using to write this new one, and you can do funky things like this, and you can expand YJLC over PCB. Don't know. I've used PCB way. There you go. PCB way. I've used them. In fact, I've got a load of circuits in here. Yeah, they've made them fully loaded PCBs, but these are just Amiga power 2,000 power supply cards. Someone else's design. Then I've got JLC. I use both of them, but mainly JLC PCB. Yeah. So we've got this here. This is got the ability for voice commands. Let's ask it what time it is. UPass, what time is it?
The time is 8:37 p.m.
UPass, what time is it?
The time is 8:37 p.m.
UPass expand 8.1. UPass expand 8.2. UPass collapse all engines. UPass expand window. I forgot the command for that. What is it? Expand window. UPass expand window. Oh, it has, but it shoved it over there. It's gone onto the other screen. Hang on. Here it is. So you've got expanded window here. Alright. So expand the rack, then you've got your tree view down here. And you can run a script. Run a script from a script and all the rest of it. Yeah. So much stuff you can do. It's crazy. So I was thinking of putting my radio in here in part of the rack, so you can expand the rack and look at the settings in the rack. Scroll down, you can open the settings. You know, it's crazy. It's a list view within a list view within a list view within a list view. Anyway, so let's shrink it back down again. And you can run a script. So you can run a script. The script can execute stuff like so. Yeah, it's crazy. So I'll get rid of that script. I'll come over here. I'll expand it one last time. You'll like this if you like computers. I've got a script here for running the war games. Ready? Here we go.
Greetings, Professor Elton. Excellent. It's been a long time. Can you explain the removal of your user account on June 23rd?
Well, that's running a script. You can open the script.
Shall we play a game?
Right. Oh, I've got always on top. Hang on. Always on top. So I switched that on yesterday. I switched always on top on, so I don't need always on top. If I want to show you what's behind it, hang on. There we go. So, yeah, you got your script, and you can have a look at your script. So I've got scripts for all sorts. There's the war game script, so I'll open that. How do you open a script? Load a script. Here's the script for war games. Now, this is like an old Amstrad computer. Own Jarvis. Well, this is all done locally. It doesn't use any clouds. It uses the Windows narrator and speech. Doesn't use... When it comes to programming, you just got to use what you know. Everyone's a massive learning curve. So this one, I can just do things like list, and I can edit stuff. It's just like an old basic program. You set your tick delay. I can alter the tick. So if I just go tick 5 tick 500, it'll all go a bit wrong. If I run it, it's going to go through too fast now. And you can go crazy. You can run multiple scripts. And I can run a script from a script. So when you create a new script, what's your name? Acid Cows. So we'll create a new script called Acid Cows, and I'll just put 10 tick 1000. So I'm telling it, the tick 1000 is just telling it what time to execute each line of instruction. I work in the cloud all day for work. All my personal projects don't use the cloud at all. It either runs on a Pi or Arduino or on a server in my basement. Yeah, fair play. The cloud's great, but I mean, the way I see it, you've got loads of people using the cloud service, and you send in we use commercial stuff at work, and it's dead slow. You have to keep refreshing the browser and all sorts. It sticks. What it is, you're sending your data to a central place, a server, that loads of other people it's going automatically to there, and it's going in a queue ultimately. It might be a quick queue, but it's going in a queue, so you don't know if it's busy or if their network's down. You can't even switch a light on. So anyway, this is done locally. So you create your tick, say hi. How's it going? This is going off on a bit of a tangent, but anyway. 30, I don't know, what can we say? I don't know. Yeah, it's just like a basic program. You can do what you want with it. Just say delay 5, which will be 5 clock cycles or instruction cycles. You can play an MP3 from here or video, anything you want. Say hi, say goodbye. Goodbye. Okay. Right, and you can list it. You can save it. You can question mark. It gives you all the commands. You can log in with this as well. This is good. You want to watch this? Look. Log in. Right. I don't know how to spell maze. Let's try that. I don't know. Can't remember. No, it didn't log me in. Let's try again. Do I get rid of that? Can't remember. Yeah, it's logged me in. I don't want to be left with a bunch of non-functional stuff because I've lost the internet. Local is faster, cheaper, more reliable. Yeah, fair play. Well, I'm in super user mode now with this. I've just given you my password. Falcon's Maze. Anyway, if you like war games. So if I log out. Funny, isn't it? Anyway, so once you've listed your whatever you want to say, you can run it. Just wait. And if you want to repeat it over and over, you can just put a little go to 20, run it. And you know what it's going to do, it's just going to keep repeating it over and over again. Well, stop that and we'll make a change to it. I'll go 10, tick, what should we say, 200, run it. Anyway, so we'll exit that. So if I run the war games, so if I run the script, where's the run script? Oh, we are. See, it's playing war games in the background. This is where it gets mad. Watch this when I do it again. 2 war games running. If I do another one. And another one. Yeah, it's crazy.
Shall we play a game? Fine.
Yeah, these will just finish off anyway. And you can close them. It'll stop on its own. Anyway, so you got all sorts of going ons here. Anyway, that's fine. So it's basically an access control and automation, but you got like you can do an about, site details. Anyway, that's beside the point. So what I'm stripping out code from this to use over in my, because it's servicing all this is like a piece of rack. I don't know whether you've worked that out yet. This is it's like a virtual server rack front end. You can have as many as you want in this list. That's serving one device and another, you know, at the minute. So I can trigger stuff like unlock stuff and, well, I don't know, too big to mention. Oh, your voice commands as well. You pass, what time is it?
The time is 8:48 p.m.
Yeah, so you can do stuff. So that voice command we can put onto the radio.
Using UPass.
You're welcome. Alright, so going back to this one, am I ready to run it yet? No, let's carry on with this one. So he's going to try and do all them. I need to do next serial port. So what I need to do is so I need to do a bit of an if on it. So if next serial port is equal to 0, then we'll do that. So I need to give them all their own number, so it does not do them all in one go. And we'll do that one as well, and that will be 1. Let's just sort this formatting out. Right, so we want same there.
Good evening.
Let's just put these in. Let's get this running. We'll get this running.
7 November, Mike India. Name this way is Carl, Kilo Alpha, Romeo Lima, Home QTH of Colchester.
Okay.
Essex.
So, right, we've got an extra line there, and there, and there, and there.
Yeah, thank you, Carl.
So, we're just going to go down the list and
Carl, I think it was.
just give them a separate number each.
Yeah, it's a beautiful evening here in North Wales, but everybody
Else,
my wife has gone to
back to the S meter. Okay.
Consecutive. He's in another room, not together.
Yeah, we can do the S meter. So we'll put that 7.
Pull the radio out, stick on hop that, and give a call out. Anyway, good evening. I wonder.
Right. So. Okay. So we're going to do that, and once we get to a certain point, we need to put the counter back to 0 again. You can either do it there or at the top. So when it gets to 8, we'll just do a if. Oh, we've already got the if there. Hang on then. Let's get rid of that. If next serial port equals to 8, then next serial port equals 0. That's it. Okay, so we're just going to reset the counter when it gets to 8. So it does each one of these only once every iteration. So will it do it? Yeah. Yes, it won't. That'll do. You can make that equal 0 if you want. Doesn't matter. Right. Let's try it then. Let's see if that will work. See if it'll compile.
I'm in Wales, so it's about Mike Whiskey 0 Whiskey Tango X-ray.
The reason I started using C# and Windows Presentation Foundation back in 2012 was to use what it was the latest stuff then at the time. I thought it's no point learning something old, just bite the bullet and learn something, get into the deep end with it. So that's built successfully. Let's just run it up, see what happens.
It's beautiful sunshine here in Wales all day.
Let's run it up. Okay, so I've not clicked anything this time. I can already see it's performing stuff.
Just amazing.
Can I still do that? Yeah, I can still do that. Can I?
When it said it was a bit cloudy, so,
Yeah, that's not as responsive now. See how it's lagging compared to what it was? Because it's doing it every so many milliseconds.
I wonder what your weather's been like.
So if I transmit now, G7UIV test only, G7UIV test only. So, because it's only doing one, it's only doing one every packet dispatch. Well, every dispatch of this timer, this serial port dispatch timer. So what I could do is increase the speed of that really. It's time interval from 10 milliseconds. And the old way was waiting. Where's it gone? Yeah, it was waiting. Task delay of 10 milliseconds, then doing the next one, then the next one, and the next one. So, and that was going through, it was doing all that in one go. So that is a bit weird because you'd expect, because I've got 10 milliseconds per instruction.
Very well. I'm hearing you, no problems at all.
Yeah, because it was doing it through every iteration.
I sound okay to you. Analog FM, and you're in digital, so you'll hear whatever you.
S meter, yeah. I don't know. Let's see if we can make it a bit faster. I trained in C and C++ years ago when I became a Microsoft engineer. Now I just don't remember it. Yeah. Oh, I didn't know that, Andy. Well done. Yeah, well done. Well, I used to do Pascal, Turbo Pascal for DOS. Turbo Pascal. I wrote a whole program in DOS. I wrote Windows buttons and everything back in 1990. When did I start it? 95. And the guys who saw the program, they said it looked like novel NetWare. So that was to control access control system. I wrote one from DOS-based one years ago, barcode access control system, and that was just running on a Windows 386, I think it was, something like that. Yeah. Yeah, running the whole site on a 386 computer, crazy. Yeah, C++. I mean, I don't do all the fancy bit shifting and stuff. You can do it. You can't remember none of that. I just put things in lists. You know, put things. I used to do Visual Basic 4 and Visual Basic 6 programming. I've done Flash ActionScript 3 programming. I wrote a whole website, a dynamic website in ActionScript 3, and it used to draw everything on the fly. You need a Flash player to run it though. So since Apple didn't want to let Flash player run, it all went to pot. But I had animations going on before. This was before HTML5. I had animations and all sorts going on in the website. To spend a lot of hours. That's where I learnt some of my stuff. I translated it straight over. I tried that. I tried ActionScript and I tried a few other languages, and I ended up in here in the end. But the latest one is Maui, I think. Is it Maui? If you want to get into Maui. But a lot of my code, serial ports and stuff, don't run on Maui. You have to use different serial ports for different operating systems. You know, you got to. There's ways of doing it. Sharing the code. So let's speed this up. Let's say 3 milliseconds. It just seems too long. Let's try it again. Yeah, actually, I've I put on my my Facebook. I put years ago when it first started. I put a joke on it. I said I work at. I'm a think tank at Sun Microsystems in Lafayette, California. That's a funny one. Yeah, there's a definite delay there. Look at that. I'm turning the thing, but there's a lag. But there wasn't a lag before, so the dispatch time is weird. Oh, it's the way I've done it. Yeah, so. Yeah, so. It's working because it's going through it, but what it's doing is it's quitting. So the dispatch timer, I need all I need is a delay from it. Right, I'll tell you what, we'll put this. I'll put this into ChatGPT, and I will tell it. I'll show it the other one. Alright, so new subject. New subject. Oh, spelt it wrong. Right, so C#, Windows Presentation Foundation. Dispatch timer. A dispatch timer is running my code slower than in a async await task. See if it knows what I'm talking about. Will often feel slower or less consistent than an async await loop, but it does not it's not really about speed. It's about how and when the code runs. Well, yeah, I suppose so. Runs in a UI thread, executes via the dispatcher queue. Right. Await task plus task. Right. Why dispatcher feels slower? Won't fire every 10 minutes reliably. That's not good, is it? Async loop comparison. Do work. Yeah. Okay. So we could probably do. Yeah. Right. Let's just give it my code. Oh, run out of messages again. God, hang on. See what it makes of that. I'll say, yeah, that's why. Time slice serial polling loop, and it's exactly why it feels like inconsistent with the dispatch time. Let's break down what's actually happening and when it behaves like that. Slowing poll difference, real problem. You're using a UI thread as a scheduler. This line is core issue. So every call is happening on a UI thread, blocking rendering input while it runs. Your round robin scheduler depends on a UI timing logic. Yeah, timing is not real time. If you are artificially throttling yourself, yeah, probably. Each function runs why async feels faster if you switch to async. No UI thread blocking, no dispatcher queue delays, no consistent. Async await runs faster than dispatch timer. Because no, I'm not waiting for the WPF's UI message loop. Better architecture recommend. Move serial logic off the UI thread. Async loop, simple and good. Right, okay. Cancellation token. What's that? So it's made something else for me. Await delay 20. Okay, we could do that then. That saves having loads. Token. What's a token? Token. Cancellation token. CTS. Don't know what that is. Use distribution only for UI updates. Okay, that's what I was doing. Well, it is a UI update. Ultimately. Your current design is UI thread pretending to be a scheduler. A better design is background scheduler feeling UI. If this isn't a cat radio control, what would it look like? Dedicated serial thread, queue-based commands. If you want, I can refactor your whole pattern into a clean producer consumer serial system. Usually what? Yeah, okay. Do it then. Just do it. If you want to improve it later, got it. Do it now. Do it now. Alright, let's, yeah, clean, do it. Right, so I've got serial. Run the task. Right, task serial loop. Okay. That'll do. UI save updates. If any function updates, UI wrap it. Or better, dispatch beginning vote. Yeah, I've used that before. Right, let's do that then. Let's start it. Right, so let's get some of these on the go. Right, let's put some of these in here. So we'll just run that there like that. Put that there. We won't start the timer. Where's the start? Well, we'll stop. We won't start that yet then. I'll take that out for a minute. And we'll have to turn that off for a minute. Right, and then we'll have to copy the next bit. Where is it? Start it with so put that in here. Where is it? Loaded, and we'll put it here. Serial loop. Right, we don't have a function called serial loop yet. Stop serial loop. Actual closing. Let's put that here. Stop the serial loop, and then we want this task scheduler. UI safe, we can sort that out after. So we want put that just here. Okay, we've got everything there. So that should run now. Has it changed anything? So it's put it in a switch case packet 0, and then it's doing packet plus plus. Yeah, it's the same thing. I think we can do 10. Right, let's just go for that. See what happens. Oh, hello. NLMK 10:10 PM. Hong Kong time, ocean, Atlantic status. Stranded off Cape Verde. Situation as there is a new virus. H antivirus transmission. Right. Okay, whatever that is, yeah. Well, don't know what that is, but welcome anyway. Let's see, we're just going to welcome you. I don't know what it is. We'll welcome you to the stream. Right, I was just about to try this. Let's see if we can compile it. If it's any better. Right, let's run it. See if it's faster. It should be faster now. But I am updating the UI though. Right. That's better. Yeah, so it's back as it was, isn't it? It's just a cleaner approach. That is faster though. It's the same speed as it was before I changed it. Right. G7UIV checking access. G7UIV checking access. Checking access to nothing, just testing. Checking access. There's no repeaters on there. Oh well. Yeah, so that's okay. We're going slow. Right, so that needs to be updated. I need to update the UI no matter what. Right, okay, so that's good actually, because we're using an async, I can automatically put in one of those wait states. This a task delay. Let's go down to here. Where is it? Here it is. I can put in a thing after the oh, hang on. It's slowed that down, hasn't it? What am I doing? Hang on. Yeah, because it's... Well, I forgot what it's doing. It's changing the frequency. Yeah. So the frequency, that needs to execute no matter what. So let's go back up. We need to do that anyway. So the frequency there, that needs to do it as well. So even no matter what we're doing, always want the frequency back, because that alters the knob. Maybe. So we'll do that anyway. We'll do that and then we'll just do the next one. So we don't really need that in there. We'll just leave it out. I need to shift all these up, don't I? Let's just get rid of that and just make that one. Just move these down a bit. I want the knob to be quick. Right, so that's okay. But then we want to do 7. Yeah, okay. Right, that should be better. Let's give that a go. Is that the ship where they had 3 deaths, right? Cape Verde, where's Cape Verde? Right, so I'm able to turn that, and I'm able to... Oh. What's happening? Why is that not changing the knob? That's weird. Wonder why is that not working? So it's requesting that. That's weird. Right, 0, 1, 2, 3, 4, 5, 6, 7. So it goes from 6 into 7. If it's 7, go back to 0. And it's just await task, await delay. Was this the one the same? Yeah. So transmit state S meter. No, that shouldn't have done that, should it? That should be okay. Don't quite know what happened there. We'll try it again. So we move that. That's not making any difference. So that's responding quick enough. But I'm no longer tracking me tuning the knob. Oh, it's no longer doing TX. It's no longer tracking this frequency change. I never noticed that. So I'm turning the knob and it's not changing. Oh, well, not dragging. Yeah, that's okay. Maybe that needs to be down here. Walnut token is cancellation requests. Okay, so I can put it here. That won't make much difference, but... So that worked when it was in here. I don't get that. Let's have a look down here. Let's have a look in the cat handler. Right, the cat handler is here. So what we want. That's the transmitter state. Then we want update the frequency. So update frequency, change the frequency, spin the dial. If current frequency is not equal to the last frequency. Ah, so it's the frequency. Won't spin the dial because the frequency hasn't changed. Ah, frequency label content. So it's not updating the frequency. We've lost something somewhere. Current frequency is frequency. We've lost something somewhere. So this is the old one. 1-2000, it's using a weight. And you got the... Yeah, there's nothing there. So, that's weird. So if we're going to do this, we might as well just put the await state after each one. But the only thing we're doing is we're going in a loop. Yeah, I don't get it. Don't get that one. Anyway, we'll... So, there's something not quite right there. I don't know what though. Unless it's going too fast, you know. Could be going too fast, couldn't it? Let's knock that back down. Just to slow it down. Maybe it doesn't want to go as fast as I've put it. We used to, but anyway. Let's try it again. Right, so it's just about trundling around now. Oh. So it is moving. It wouldn't move at all before. So it was obviously too fast for it. Oh, there's a lag on that now. Yeah. It's working, but there's a lag on it. Testing only. G7UIV testing only. Yeah, it's definitely a lag on that. So, whatever we've done, we've made it worse. We've made it worse somehow. I don't know how we made it worse. Hello! Welcome! Amatunku. How are you doing? Thanks for putting us on that, whatever you put us on link the other day. You ended up a few more subscribers. Thanks for that, mate. I think that was what did it. I subscribed to that one, that channel. It hasn't offered anything up for me yet, but I will have a look another day. Right. So that's quite slow still compared to what it was. I'll tell you what, let's switch that off. Let's stop this running for a minute. Omar. Okay, Omar, yeah. I'll try and remember. My memory's not brilliant, but I'll give it a go. Say welcome, Omar. Yeah, Omar. Anyway, it looks perfect. Oh, it looks good, yeah. Yeah, I just want it. I mean, we put some boilerplate code in, it ran quite fast, and we're trying to make it better. Execute, but then it's slowing it down, so we don't want that. So what we're going to do is stop this from starting. I'll just try the old method. We'll do it from the old method and see what happens. See if it speeds up again. Right, so nothing happens until I click this button. So I click that button and I turn the dial. Oh, it is quite slow. So I'm spinning it, and then you can do that. Yeah. So it is quite slow. But I can make that faster because you got. And then you transmit. G7UIV testing, G7UIV testing. Yeah. Yeah, so it's just the knob animation that's slowing down. Now I've got all this meter reading going on. I found someone there. Yeah, so it needs to go around a bit faster than it. But that's just a bit of animation. Doesn't matter. We'll sort that out another day. Right, anyway, so what I wanted to do, so is that any better? I was going to do the dispatch timer. Don't forget you have to be able to turn the radio on and off. Yeah. Turn it off, on and off, you're right. Now, I think ChatGPT said you couldn't turn the radio on. I don't know if you can turn it. If you turn it off, you can't turn it on, apparently. I don't know if that's true or not. So anyway, do we get back to this? I don't know what to do with this. So what I wanted to do, let's just turn that off a bit. What I wanted to do today was frequency scan. I wanted to create a frequency scan. So yes, we did the meters last time. Yes, we'll improve the cycling of it. But I want to do the scanning now. I want to try and scan how it's going to work. You choose your band, you just go on your band and you do a scan. There's so much I wanted to do, and yeah, it's easy to get diverted, isn't it? Easy to get diverted. So is this timer, dispatch timer, any good or not? No, that one isn't any good, because it's using a dispatch timer which is a bit slow. Great for UI. Well, it is the UI I want to update ultimately, but don't know what's going on with that. So just knock that out for a little bit. I'll keep it there for now, but I'm just gonna highlight this out for a bit. And this one out for a bit. Or do we keep that one? No, let's keep that one. Let's have that one running. Yeah, we'll have that one running. We'll use that one. It is a bit slower, but yeah, we'll have it running. So we want to turn it off. So stop the serial port. Loop. So hopefully that, if I put that in here, when we close it, it'll just stop it, maybe. Right, so let's just run that up now, because I'm trying to get rid of the start stop button things. Trying to get rid of this. That automatically starts and responds to TX. G7UIV testing. G7UIV testing. It is a bit slower. It is slower. Hang on. Is there anything I can do? Right, so we're on 10. I'll wait 20. Let's go back to 10. It's gone faster now. Yeah, it's gone faster. Right, oh, it's bound to go faster, isn't it? G7UIV, test. G7UIV, just testing. Testing only. Yeah, they're not responding quick enough now. I had them much better than that before. So let's do something stupid. Let's do something stupid. Just one last go. It's trying to send loads of serial commands. It's much quicker if you do packets, proper packets of data. Alright, that's better. That is better. Right, let's see what it's like to respond to my G7UIV testing. Test. G7, Golf 7, Uniform India Victor. Testing only. Test. G7UIV testing. And if we go to a different band, the SWA's going to be out, so you'll see the SWA meter go up. I'm only on 5 watts. Is the frequency in use, please? G7UIV testing only. G7UIV testing only. Test, 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 test. So the SWR went right up then. So that'll do for now for what I'm trying to do. So anyway, I want to introduce the scan. So basically what I'm after, if I run it up, what we want to do is we want to press a button somewhere, just a temporary button, and it'll go through all the memories of the band. Go from this, it'll well, you might want to do CW section, probably not, but so we'll just start on the voice section, go through one setting at a time, or one clear channel at a time, whatever they call it, and anything over a certain signal strength it memorises it. So it would have to lower the ALC on purpose, so it would have to drop the ALC, and when it's finished it would have to raise it again. So every time it found a signal strength that came up, so the ambient signal strength, every time it saw something, hang on, like that, yeah, so that's right in the back of the box there. It's right in the back of the box. So I want it to scan. So if it's on fast scan, it would have to go to 7, 6. Yeah, my 40 meters aerial's not so good. Yeah, so it's dropped there to 5. It's gone to 9 there, 9 plus. So if it's go to each channel, anything over the ambient, store that channel number. Yeah, so store that. So we need to create a list. First we need to do a class. I need to create a class, scanning class. So I'll go File, New, Class, New Item. It's going to be a class, and it's going to be. So what should we call it? Scan. It's a seek, find, scan. So it'll first. It's a scan with a difference. So it starts every frequency. It goes up 1, not in hertz, but obviously in 1000 hertz or whatever. Goes up. If it doesn't see anything, it jumps to the next one. It doesn't store it, and it only stores the one where there's some activity. Yeah, so what we're going to call this search. I don't know. Intelligent search. Yeah. I don't know. It's too long-winded. Intelligent sounds too long to say. Find. Search and find. Find stations. No. Find. I don't know. Find active frequencies. I don't know what to call it. Oh dear. I ain't got a clue what to call it. I don't want to ponder over too long, I'll just call it anything. I don't know. Seek scan. I call it station. Station seek for lack of anything else to call it. Right, so we're going to make it a public internal class. Public class station seek. So in here we've got to create some stuff to do with the seek. Now we want to store we're going to store. First thing we'll do is we want to know the frequency it's found something at. So we're going to do let's just do long. It should be a U long really, shouldn't it? It's not going to have decimals. U long, and we're going to call it frequency. Frequency, okay. Then we want, so store, it needs to know the frequency. Then we need to know the number of times it scanned it, or number of times it was empty. Yeah, number of times empty, so it can take it out to scan. If it finds that if it's scanning it and it found that it was empty more than a few times, no point scanning it again. You can initiate a new scan where it scans them all again, but so I'll just say int times empty. So number of times empty. It's a bit of a weird name. Right, number of times empty. Oh, hang on, I've got to make this public. 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 Right, so number of times filled. Why is it set? Why is it telling me that? Number of times empty. It'll only put this in there if it's found something in the first place. Number of times empty. The frequency. Won't necessarily know the mode, will it? It won't know the mode. But you're on the band. You're doing it by band, so you'll be in the mode anyway. So that's fine. So what else can? Oh, signal strength. It needs to know what the signal strength that it found. So int. Right. So number of times it was empty. And the number of the signal strength, yeah. Signal strength. There we go, signal strength. What else do we look about the character? There's nothing else we can really do. What frequency it found it on, the signal strength, and if it once it needs to keep a count of how many times it scanned it. If it finds some signal on it, it's reset the counter to 0. So if it counts 5 times, and if it looks 5 times on the same frequency and there was nothing above a certain signal level, it will just abandon it. If it gets to 4 times, then it finds something, it reset the counter back to 0, so it counts up again to 5. Or whatever the 5 is, yeah. So all we need to do is store the frequency, the number of times it was empty, and the signal strength, the current signal strength. Right, so the current, or the signal strength will do. Okay, that'll do for now. Right, so then we want to create a list. Let's go over to this one. Right, so list of events now. So is it a list or a dictionary? It'll be a list. Do I need to reference it? No, I don't need to reference it by any particular name. So that'll do for the formatting. So it's just a normal list. So I'll create a list over here at the top. Let's create it there. Now it's a list of station seek. List of station seek. Okay, so we created a list of station seek. So we need a routine or a function. We'll keep the functions in the same thing, I think. Actually, that can just be put with it. Actually, let's take it all with it. So cut that out. I'll keep it over there. I'll put it here, but it's not going to be appearing there. We need to another. That's the class, but we need a. Let's just put it in for now. I'll sort that out. So that can't go there. It's got to be in the main. What should we call it? So we've got the class. So we need this down here. Hang on. Let's get rid of this. Put it down here. Oops. Right. So we need a public class. And it needs to be the name. Seek, station seek. What do I call this file? Station seek. So it needs to be that. So we'll call it that. And oops. Right, so we're doing it a bit of a hard way. So this one will be the class, station seek class, that's it. That's better. And we'll put that in down here. That's it. Put that down there. And so list. So it should be a list let's call it active. Right, station seek active list. Station seek active list. So it's a bit weird. Yeah, never mind. So we're making that a public. No, static. Do we make it static? Public static. Might as well. Public static. Right, so that's a static class. You can always get to it. And we want a few. That's the constructor. And within here we need a function. So public void name of the function. Right, so the first function we want is add station. Add a station to the list. So add active what's all these noises? These phones are just annoying, you know. What's happened to that? In the post. So this, guess who made the cut? I'm being harassed by AI. Right, so add active station. Add active station. I don't know. Let's just call it that. Why is that? What's that doing? Why is that doing some rubbish? Oh, so that needs to be. Yeah, sorry, that needs to be moved to here. But that's it. That's the main thing. But we need a constructor. Or is this the constructor? I don't know, I forget now. Let's just have a look at something else to make sure. I don't know what I'm doing anymore. RG console, let's have a look at that. RG console, public static class, RG console. Yeah, you don't need a constructor, but you can have one if you want one. Yeah, I've got two classes in one there, so I think you pretty much make up whatever you want. Right, public, so we've got a, in our seek, so we've got a list. It's already initiated, public static. So this needs to be static as well. Right, so we want to add one to the list. So we've got to go, and we need to import the seek class. So we want one of them coming into here. Seek class, station seeks class. There we go. So we're going to take that class and do something with it. So we're going to get that. So we're going to add, and then that's it. Add the seek class. That's it. We need another one to remove the class. How do you remove it? I don't actually. Yeah, that's an idea. Remove station. Remove inactive station. There we go. So what have we got here? Oh, this is where we need a dictionary to find it so we can delete it. Remove. Removes the first occurrence of a specific object. I need an ID number though, won't it? Remove that. Remove. Let's just say remove for now. So we'll remove it, but yeah, it might not necessarily work. So we've got them, so we should be able to use that now. What we need is a search. We need a public static void search band seek station seek start. I don't know. Start a station seek. I don't know. It's just too rusty for this stuff. Hang on. Public static void. I don't know. I've forgot more than I know now. So we need to start it seeking. So we need to give it a start band. Public static void seek. I'll just call it seek. So we'll need a ulong. We'll call it a start frequency. Start frequency. We want another end frequency. Yeah. Start frequency and end frequency. Okay, so it's gonna have to wait as well. It's gonna have to wait and interact with the stuff. That's gonna be difficult. So it needs to go to its frequency and get the strength. Yeah, it's gonna be complicated. This is. Yeah, it'll be complicated. But anyway, we'll be able to do it, but it's complicated. So seek. So seek active. Seek active stations. There we go. So what we're going to do, we need to do a start. Yeah. Well, we need to generate. Yeah, we need to generate a list. Yeah, it's going to have to generate all the numbers in between. And it'll need a step in kilohertz. I'll hard code it for now. I'll just step 1000 hertz. 1000 hertz at a time. So we can either generate the frequencies and search it, and then store the ones that are in a separate one. That means we have to maintain two lists, or we can just do a start. When it gets to the end, it'll have to scan it again. So while it's scanning, it needs to do not much else. Yeah, it'll have to suspend other activity apart from the S meter, which is probably okay. Seek active stations, right, okay. Start frequency and frequency. So if we do a 4 next loop. Can I do an async, public async? No, because it's picking it up in a separate place. So it's going to have to come back to the receive bit. So it can give the command, then it's going to have to come. The handle cat's going to have to sort it out. So it's going to have to read the S meter. But it'll be constantly reading the S meter anyway and changing frequency. So all we need to do is be able to read the last S meter. So where is the S meter? That's the TX. This one here. Oh, read the meter. Yeah. So that is going to have to be a... Need to set a reading so we can read it from elsewhere. Meter to update. So there's your meter reading, update and meter reading. So yeah, we can do it from in there. So go to the definition. Here's the meter reading. It doesn't know which meter. We need to do an if cat value rectangle. No, let's go back. Right, so yeah, it's already determined which meter, so we need to put it in here. So we need a global variable. We can put the variable here. We can put it here. So we're going to call it public static. And it's going to be the last S meter reading. Public static, and the S meter is just a byte. Byte or an int? Does it matter? No. Right, so last S meter reading. So we need to go back to this and update the meter. And we just need to say last update. So we're going to need station seek. Station, oh I can't spell, station, too many. Station seek last meter reading equals meter reading. There we go. And meter reading is probably an int, so we need to try and convert it to tell you what, let's just call that an int, it's easier. Right, okay. Int. Right, so I'll just, yeah, every time we read the S meter, we'll update the last reading. Okay, so that will be able to go over to here. And yeah, we need to do async. Can we do async? Yeah, do static async. Right, okay. So we're going to do a for U long, this is a bit of a weird way of doing it. U long F frequency equals start. See, it's good this AI, it's done it all for me. Right, it's done it all for me. Frequency is less than or equal to n frequency plus plus. Ah, now frequency, hang on. So this will be int, a uint, and it's going to be frequency step. Frequency step, and so if it's less than or equal to the n frequency, plus equals frequency plus equals frequency step. Yeah. Frequency plus equals frequency step. Okay. So okay, so once we need to issue a signal strength command.
Just remember, you've got to leave a bit of a gap, or you won't get your talking. You have to leave it before you come back in. Yes, understood. Is that enough time? Yeah, that's it. You have to wait for the bleeps to go before you come back in.
So
you're working well there, Dave. M6NQM.
S meter.
Yeah, this works well on the upnet as well. That's good. It actually works everywhere. Yes, I've rolled on to that. What is worth holding on to, mate? Yeah, go back up to 450 a minute, 450.
It won't know what this is. Why doesn't it know what it is? Hang on. Repeat the definition. That's in the dictionary. Right, so we need to add dictionary to that one. Right, it doesn't know what port is, so we'll have to create a serial port. Okay, now it knows what it is. So it's going to go through that. It's going to send a meter reading. Yeah, it's going to get this. It's going to change the frequency. So we need to change the frequency. There's the frequency on A. Right, we need to change the frequency. So first we're going to have to change the frequency, and the frequency is going to have to be frequency. So it's going to have to, what are you long? Oh, it's a long, is it? Okay. I should have made that. let's just make it a long. Doesn't matter. I don't care. I don't care. And we can make all these the same actually. Right, so stop that from being a U long. Just make it a long, I don't care. Right, where did we get to? So it'll send the frequency out, it'll wait, then it'll read the meter reading. No, it won't. Yeah, it'll request the meter reading and it'll wait 10 seconds, and then we need to read the meter reading. So then we need to do right. Now we need to do a compare. We need to say to it, right. This is going to be a bit of a weird one. So if where's that meter reading gone? No, not last frequency. Where's it gone? What did I do with it? Did I stick it here? What did I do with it? Last meter reading. If last meter reading, no, it's not going to be frequency, nothing to do with frequency. If last meter reading is greater than, I don't know, what can you say? You need to know, we need to determine, I don't know how to say something for now. If it's greater than 5, let's say 7, 6, let's say 6. Right, if the reading was greater than 6, store it. So that's it. Add it to the station. So we want to do there's a new seat class. Right, so the frequency equals freak, and number of times empty. Right, that'll be not needed yet. Won't need that one at this point, so we'll say signal strength. Oh, number of times empty, let's just put it in for is 0. Signal strength will be last meter reading. Okay, that's it. So that'll add that to the list. If it's lower than, if it's equal, greater than, equal to 6 for now. So we're just going to get to scan through and make a list, and then it go through to the next station and keep adding the frequency till it gets to the end frequency in steps of 1000 Hertz. And if it gets to the last, yeah, so all I've got to do, let's try it. So if I just copy that over here, so I need to start that off now. So I just need to go in here and assign it to a button. Which button? Stop. Stop doesn't really do nothing. So we'll call that start. Start station seek. Okay. And we'll call that start station, too many T's, seek button. Go to the definition. So we want to run station, too many T's again, seek dot start station seek active stations. Right, start frequency 14,200. And we'll, oh no, that's the port it wants first. So it wants underscore port, and that's your start frequency. Then your end frequency 142 to, let's just say 300. 300. Is that it? Oh, the step. And 1000 hertz. Okay. Right. So we're going to start that. Now, you should see it all going on. Right, you should see it all going on. So it's going to issue. Nothing might not get stored. It might not like it. Port A. And all the time this is going on, it's going to. Yeah, we need to stop when we're doing this. We need to stop the normal goings on. Oh, hang on. Yeah, I need to stop the stop button. Well, we'll leave that there. Yeah, we need to stop the. We know we can stop it. Right, where is it? Right, serial loop. Stop serial loop. How do we start it? Task run. Serial loop. So cancellation. Token. So stop the serial loop. How can we start it again then? Oh well. We'll just do that. So we'll stop it. And let it do its scan, but then we can't carry it on again. Task run. So what are we doing to stop that? Let's have a look. Stopping it. Cancel. Communicate a request for cancellation. Okay. So to start it, I think we have to do that again. Have we got to start? Right, so we cancel it. So we cancel it, and then we have to start it, so we need another function. So let's make a function to start again. Public void start serial loop. So we'll put the start, this bit. It's a new, okay, so we'll do a new, yeah. Let's do it. That should work it. So we stop it and we start it. So we'll go into it and go into here. So we're going to stop the loop, and we don't know where it is. Main window. Stop the serial loop. It doesn't like it, so we'll have to make it static. Right, cancel reference cannot be non-static field. Okay, so we'll have to make that static as well. Private. Public static. Public static. Right, so we're gonna go public static. Right, serial loop. It doesn't like serial loop because we haven't made it static. Public static async. So it doesn't know what his dragging is now. So we'll have to make his dragging a static. Oh, enable drag. Oh. Okay. Is that going to cure it, or is it going to open up some more can of worms? Port. Doesn't like port, because port's got to be static. Right, what else is it going to... So do one, it opens a can of worms up. Tranceiver state. Tranceiver state, where are you? It's not there. Where's that? There must be a variable somewhere called transceiver state. There it is. Yeah, it's horrible coding this is. But right, let's see if we... Okay, no. Yeah, we're okay now. Right, okay, so we run that. So that's okay now. So we stop the serial loop. And then we've got to start it again at the end. Stop, start. Start the serial loop again. Right. So we're going to store. So this will scan through them. It'll take the S meter reading, store it. If it's over 6 signal strength, store it in this list here, and that's all it'll do. And if we do a console write, and we'll put a little thing out to just say count is so we're going to say count. There we go. So it'll tell us down here if how many it's stored. We should be able to see this happening. It might crash. It might say UI thread problem. Could be all sorts of things. Let's build it. See if it got any problems. No problems. Let's run it. What's the worst that can happen? Electronics, it'll set on fire. What's the worst that can happen here? Crash. So that's the normal state of affairs. Okay, so you can... Oh, I'll tell you what we didn't do. Drop the RF level down to nothing. I'll have to do it manually for now. Right, here goes nothing. Ready? Start station seek. It's actually doing the frequency but not on the screen. That's because I've stopped it doing the It's actually not stopping. Oh no, it's going. It hasn't stopped. It's gone right to 15 now. Let's stop that. Something. Yeah, it's gone over to 15 meters. 15 megahertz, sorry. Right, it's gone past. So what did I do wrong there? Something's not quite right. So, end frequency. I passed in the end frequency. It's down the bottom somewhere, wherever it is. Where is it? Here it is. Have I got too many zeros? I have, haven't I? Have I? 114. Yeah, I've got an extra 0. So 142. Then you go. I've got the right amount of zero. I had an extra 0 in that one. That's why it carried on and going. But that's okay. But it wasn't allowing the reading to come back to update our display. I wonder why that was. Because I turned it off. So you've got your S meter and your frequency, but it's not updating the UI. So I need to update my frequency on the screen, on the software screen as well, so I know I can see it moving. Right, update meter, not the bar graph. Actually, it needs to do this meter reading as well. Right, so read the meter, S. Meter reading. So, oh, it's doing it there. Yeah, so, because actually, if I'm sending it, it should come back to this. That should work, so... Yeah, that should all work. But it wasn't slowing down. So, why didn't it slow down? Let's have a look. So, it stopped the serial loop. Went for a long start frequency. Frequency is less than. If frequency is less than end frequency, frequency plus equals frequency step. Yeah, so it's the frequency plus 1000. That was working. Then you go in frequency, send out the command, and your S meter. Let's try it again. Let's just try it again. I'm going to see if the UI was updated. So that should do it. That should have worked. So if I start it, oh, what did it do? Oh, it did it. It's only got up to 30 though. Right, so it's not updating the screen here. It is scanning the S meter though. Oh, it's doing comp. It's not doing the right meter. I'm not doing the right meter. I did the wrong one, anyway. I think I did the wrong one. Yeah, I did comp. Oh, S meter's down here. Yeah, so I'm reading the wrong meter. Right, let's read the right meter. Right, so we're reading the S meter. Yeah, so that's why that was never... But that should still move the frequency. Try it again. Right, there we go. Right. Let's go down the bottom. Right, it's going 200. That needs to go there and one extra digit there, that's it. But it's still not updating the meter. It's sending it out. It's sending the S meter. It's sending the frequency. So without that, it'll only do an S meter. So it's like it's not doing that. Ah, that's why. When I want to read the frequency, I need to send it. I need to read it because it doesn't do it. Right, so I need to send the frequency out. Then I need to read it back in again. So 0, and then read the meter. Yeah. This might work now. Could work. Oh, look at that. Right, did it find any? So let's stop that. It should have printed out Seek Station. At the end. Where is it? Somewhere it should have printed out Seek Station. There's lots of these here. So it went through the loop. Just trying to find it. That's the end of it. Oh yeah, it's done loads. So we'll run that up. Looking for Station Seek. So it does so many of them, you can't find it. Where is it? It's got to be there somewhere. Tell you what, I'll put an await just after this. I'll put an await. We'll wait 5 seconds. 500 milliseconds, 5,000 milliseconds. Yeah, we'll wait 5 seconds so we can see the print. Alright, that seems to be quicker than 5. Right, let's do, I don't know, 10 seconds. 10 seconds waiting. I don't think it's waiting. Right, let's start now. Yeah, it's carrying on. So what's it doing? Oh. Tell you what, we won't start the serial again. Yeah, that's the trouble, it's starting it. So we won't start it. Try it again. Let's see if we can get that number of channels. There it is. Seek Station count is 101. 101, but it is bouncing around the 6. So 101, right. Okay, and you can see it changing the frequency there, look. Yeah, going up 1,000 Hertz. Right, I'm going to go for a quick intro and back in a minute. Right, back. Right, let's make it a little bit higher. 7, because I'm getting 5 and 6 signal strength of noise. Try again. Right. 101. So why is it 101 again? Surely that can't be right. So last meter reading, signal strength, it's stored 101. Right, it's storing it every time, isn't it? That's weird. Maybe it's not doing it. Maybe I'm blocking it. No, it's not blocking. Let's give that a little bit. If last meter reading is greater than or equal to 7, store it. Maybe it needs to wait a little bit longer. Let's try it again. $101. That's weird. Oh, 200. Oh, it's just adding 101 to it. So it's not reading the meter. So it's doing this, but it's stuck in this loop. It's not going out to read the meter. Yeah, it's not allowing it to read the meter. So if I start it up, let's see what the meter reading is. So it's about a 5. 5 and 6. So if I turn it, it's not, well, there's probably nothing to read, but there's nothing over a 7. If it's greater or equal to a 7, it's not changing. There's probably nothing here to listen to. Doesn't help having nothing to listen to. Okay, we'll change it then. I'll change it to 7 100 to 7 200. And we'll go, yeah, I'll just keep it simple. Right, we'll try a different frequency. I don't think it's that though, I think it's blocking it, it's not allowing it to read it. But it is making the meter read. No, it can't be. blocking it. Let's try it. $101. It's stored 101. That was definitely moving up and down. But so it's moving, but have I put that thing in the wrong place? I reckon I've put it in the wrong place, haven't I? Yeah. Oh, that's S meter. Last seat time. Meter reading. Read the meter. Ah, it's definitely S. Yeah, it's definitely S. But it's not changing. The update the meter's working. So why isn't that changing then? Right, I'll tell you what we'll do. We'll write the reading down every time. We'll print it out. I'll go here and we'll show us the last meter reading. Last meter reading is... Alright, try again. Sorry about the noise. The static. Right, here we go. $101 again. That's weird. Oh, maybe the oh no, it's not. It's a raw reading, isn't it? I think that's a raw reading. Update the meter. So let's have a look at that. Yeah, 1 to 95 cat value. Width. So I don't know. I don't think it gives you it doesn't give you an S. Hang on. Let's open the menu. Let's have a look in the menu. Let's just turn that down a bit. Right, let's open the manual with Chrome. Right, what's that? Oh. Right, let's have a look in here. So, read the meter. Read the meter. There it is. Gives you, yeah, 0 to 255. Yeah, so it's not giving you. Yeah, it's always over 6, isn't it? That's right. I need to do some kind of calculation. It doesn't tell you the signal strength. It gives you a value, and the max value is about 128, 140. So what I need to do is translate that into something here. So it's doing it as a width. So the scale it shows you is not. It's a byte value up to 255. So 6 or 7 is never. It's always going to be storing it. So I need to find out the real value. So the width, cat value. Right, so I need to somehow get. So I need to somehow. What time have we got? 11:45. Shit. I'm going 2 hours, so we'll go a bit long. 3 hours nearly we've been going. We'll go about just over 3 hours or 3 hours, and then we'll knock it on the head. So I need to either say 195. It seems to be the maximum value. So if I just say say 200 divided by 60. Don't know. Let's ask ChatGPT. I'll show him what we've got. I have a function that. Oh, I'll just ask it. How do I convert the RM signal reading into 1 to 60 dB? It should know what it is. Right, so analog to digital converter. No, that's thinking of something else. No, that's not right. It's the rmcat command, which I can't spell which top scale is God, I forgot what it was. Where's it gone? 140, 195, or 195. 195, so 0 to 255. Do you know what I'm talking about? Right. Come on then, give me a formula. Radio light curve. What's he talking about now? I don't curve. Normalize, math clamp. Oh, what's he trying to do? RM to dB. Shit, no, I don't need that. Don't need that. Just to map. Like Arduino map function. Got it, you want simple Arduino map equivalent. So, yeah. X, I'm in, what's this? One to 60 dB. Double. Okay, let's try it. We'll try it. So we need to map the meter reading. Where do we put it there? Over here. I don't know. I don't know where we put it. Let's just put it. Fuck knows. Don't know where to put it. Excuse me. Public static double. Right. Okay. Usage. Double. What's it doing here? Right, so a double. I don't really need a double. Don't need a double. So I'm going to take... Right. So I need to do that over here. Where's it gone? I've lost it. Right, update the meter so I can do it in there. Let's do it here. So we don't need double. So RM, map RM. What's it talking about? RM. Oh my god. What's it give me now? RM max is not 195. Right, I need a SIG strength number. Say 1 to 60. 1 to 60. From what? 0 to 195. Straight line. What is it doing? Final one line function. I need it as a single digit. One to 9. Well, okay. 1 to 20, not 1 to 9. Final function in. There we go. Right. Okay, let's get rid of that then. Put this in its place. We don't need to make a function out of it. What's with all this messed around formatting? I don't need to return. So, meter reading equals clamp RM. Well, it keeps coming up with RM again. Where does it find RM from? RM. Init RM. Oh. The meter reading. Right, okay. So RM will be meter reading. So meter reading doesn't like the word clamp. Just got I haven't got a clamp. No clamp. Function. Math clamp. No clamp. No. Math clamp. C# helper restricts the value of a range. I don't have it. Have I got to show it? What's the matter? Oh my god. Math does not contain a def. Right, okay. Math does not contain definition clamp. What to do next? Manual clamp. If you want a clamp like what is this talking about? Generic but nice upgrade. Fucking hell, it just talks shit, doesn't it, sometimes? Starts talking, it thinks it's talking to another AI machine. I don't want reels of crap coming at me. I could do without it. Right. Oh my god, it's done. What's it done now? Made it even cleverer. Signal equals clamp. What the hell is this? It's giving me this shit, wasn't it? Right, we'll forget ChatGPT, we'll go to Gemini. Right, forget the ChatGPT. I have a cat troll on my YAESU. When reading the S meter, it returns a number from 0 to 195, which equates to 1 to 60 dB on an S meter scale. I need to know what the S meter reading is, not the byte value. So if the meter shows 7, I need 7, not I don't know, 87. Does it even know what I'm talking about? Right, so 0 to 5 noise floor, 30 is an S1. Right, so it's done something for me. It's done a formula. Right, okay, but I need a function. Can you give me a C# function? S meter, get S meter reading. Raw value S to 9. If raw value is less than or equal to 105, 9 is roughly handle dB over 9 range. Return S9. What? S9. S unit. If you would like to trigger update where the cat polling. Oh my god. It's gone off. It's starting to daydream again. I just need a int with the S meter value. Expecting 1, 2, 3, 4, 5, 6, 7, 60. A raw integer that represents the estimated reading. Yeah. Right, that's it. Exactly what I want. Get meter reading. Okay, let's try that. Right, let's get rid of this junk and right, get S meter reading. Right, so you want to get rid of that shite. So last S meter reading equals get S meter reading meter reading. Yeah, that's it. That can go. That's all I want. Right, will that work? We don't know. Let's see. Let's give it a go. Right. $99. Well, we got 99 out of 100. That's a lot, but it is a lot of noise on this frequency. So let's raise the value a bit. Let's say 9, 8. Let's say 8. Now let's say 9. $26. It's picked 26 channels out of 100 that are over an S9. So that's working. So what we need to do now is now scan. Yeah, that worked. Oh, let's go over to 14. 15 meters. Is there anyone on here? No one on. What a shame there's no one on. Dead. What about 3? Oh, here we got Summit. Let's do the same with 3.5. meters. Let's try 80 meters. Right, so we're going to go, that's 7. So we're going to go 3.36. I don't know, 7. I don't know what the bands cover. Let's have a look. Oops. Let's just have a look on here. Find out where the 80 meter bands are. So, telephony, all modes. Right, shall we go 3.5 to 3.7. Yeah, 3.5 to 3.8. Let's do that. 3.5 to 3.8. Let's keep it on 1,000. So 3.5. Yeah, that's it. So we'll keep that. We want the S meters a bit lower on this one. So we can go S6. Go again then. See if we can find anyone on here. Oh, 46. We got 46. So we did get some. So right, let's quieten that down for a bit. Tell you what I'll do is I'll quieten it down. I'll tell it to change the level. Set the RF gain. So it automatically shuts the radio off. Alright, so we'll set the RF gain. That's 10. I don't know what the value is. So hopefully we can shut it down. Let's see what that does, see if it shuts off. Save me turning it up and down. We need to lower it to start reading. But after it's finished, it should turn the RF gain up for me. So stop listening to the noise while I'm working on it. Alright, here we go. No, that didn't change it. Set the RF gain, I can't remember what. Right, I need to look at this. Where's it gone? Right, let's have a look at the RF gain. If I can only remember what the command was. RF gain. Here, RG 0. RG 0. Right, RG. There it is, RF gain. This isn't the way, is it? RF gain. Where are you? There it is. So it's going to give me a value 0 to 030. Doesn't tell you whether it goes up or down. I don't know. I can either try 0 or 030. Right, I don't know. So RF gain 30. 30. Is that going to do it? I don't know what that'll do. We'll soon find out. I've got it set to what it should do. Before it starts, lower it to 0. $301. Right, that didn't do anything, so let's try it the other way. Oh, it did do something. Oh, I've got a 10 seconds wait on there. That's why so it did work. Hang on. So let's just go up here. Right, so we want that on 30. But up here we want the 1 to 0. So we can have it down to listen to the signal strength. Right, here we go then. Let's try it now. So we run it. It'll be noisy. I'll turn it up. Turn it fully. Turn it halfway up. Now if I run this, it should go noisy. No, it went quiet. It's the other way around. It's the other way around. Right, so if it's the other way around, we'll put 30 there and 0 down here. They should. I don't know why they don't describe it a bit better when in the manual. They just put some tables with no plain English. Right, here we go. So we're gonna. I'll put it halfway and I'll click this. Yeah, that's better. And when it's finished, it'll put the RF gain right up. That's good. All hands free, no hands. Yeah, that worked. So it's found 32 stations. So when it finishes, it's supposed to then scan the 32. So once we've finished scanning, once we've done the initial scan, we found something, we need to just scan the ones we found slower. So what we need then is another routine here. Did we use this in the end? No, we didn't use that in the end, did we? Let's get rid of that. So now we want a public async static void, and the name of it alright, seek Seek station, then sweep, scan, found stations. That's it. So we've got our stations, so we need to scan them. So we can do a 4 each, can't we? We can do a 4 each. Yeah. This has to do a 4 because it doesn't know how many there is. And it's adding 1 to it. And it's going from 1 frequency to the end. And now we're able to do a 4 each. 4 each. Oops. No, 4 each. Right, so it's C class for each C class found station for each found station in active seek list. Right, okay, so it'll just go through it. Oh, what's going on there? For each found station in station active seek list. So what we're going to do now is we're going to scan. Instead of we're going to set. Why have we got 2? Oh yeah, we don't need to. We need just to change to the frequency of it. Change to the frequency. Okay, so we're going to change to the frequency. And the frequency, oh, it doesn't know what port is. Right, so we need to put in serial port. So we need to go station. Oh, found station. Too many T's. Found station dot start frequency. No, stored frequency, doesn't it? Yeah, it's only going to store it. What's it storing now? Hang on. Is it storing anything? New frequency. Yeah. So we just want frequency. Number of times empty. We don't use that. Signal strength. We don't need that. So we just need the frequency. So the frequency. That's it. Port 8. Found frequency. Delay 10. And we switch to it. Wait for a bit. And we could do with issuing a meter reading. Okay, so I'll give it a meter reading, and that'll update the display and bring in the frequency, and that's it. And it'll scan through them slowly, and it'll show you all the ones. Now, do we need a delay? It's going to go through them quite quickly. We need a delay. So we want to wait for so many seconds on each channel. 2 seconds. That'll do for testing. And then it'll carry on to the next one. When it gets to the end, you'll have to click search again. Or go to the start and you'll be able to stop. So well, once will do it for now. Let's try it. Just go around the once, and we'll make it do more. Keep going until someone presses stop. Right, here we go. Oh, we wrote the function, we haven't actually implemented it though. So it won't do anything yet. Right, got 37 channels there. So let's just put that up here. Presumably it's going to find something. So it's awaiting. We don't need to wait that long. That was just to prove something, wasn't it? Alright, so I'll put it in here once we've finished. Right, we'll scan him. So, I mean, because we're doing a for each, if it's empty, it doesn't matter. So it'll just do it and stop. Because if it's empty, it's empty. Right, let's go. Hopefully, we'll be able to stop in a minute. Oh, gone over the time. 3.5 hours nearly. Right, let's go for it. What would be nice if it give us a count, put a count up of stations found. Right, that's just stopped. So why is that not doing? What have we done wrong? What have we done wrong? We've put it in there. Scan stations found for each in stations active list. We've got the frequency. That's weird. Oh, we've turned the RF gain down. So what does that mean? Yeah, we don't want to turn the RF gain down there. So we want to do that after. After the scan, turn the RF gain down. Right, so we've turned it down, but we're not updating the frequency. Oh, found frequency. So we're changing the frequency. We're missing one. Yeah, to update the frequency we need this extra one with a 0 in it. That's why. So that sets the frequency and this reads the frequency. And that reads the meter. Yeah, this will work now. Right, here we go. Let's give it another go. Right, here we go. Oh, it's muted this thing, yeah. Right, so it did work, but what I've done is I've muted it there. So I can put that back up here. What I need to do now is just go in here and set the RF gain to 30, which is the other way around. Yeah, right, okay. And then when we've finished we can set it back down again to off, so we don't have to listen to the noise. Right, another go, one more go. This should do the trick. And it's just a matter of putting some nice buttons up and... Right, here we go. I should be able to see it changing every 2 seconds. Yeah, it should jump frequency to where it found them. Yeah, it's definitely noise there. Yeah, noise. So I suppose you could sweep the band and do a percentage of the channels that are noisy. Get an idea whether it's worth even getting on that band. You could check all the bands for activity. I could give you a list of all the bands which are over a certain level. I'm not doing anything here, it's doing it automatic. Oh, we found one. We definitely found one there. So you should be able to click on the band and then search. Yeah, so at least we got it working. .697, there was someone on. We'll go to 697 in a minute when this is finished. Oh, it's finished. Right, so I'm going to go to 697 and find the one that was talking. 697. That's it. Where is it then? Oh, it's turned the AF gain up. Oh, it's not. Oh, we didn't start it again. We didn't start the reading. So what we need to do is start that up again. So we need to start that up. Oops, what's it doing? Start that back up after. So and we'll get to the end of here. Need to start it back up, otherwise it won't carry on the normal functions. But we need to stop it. Stop it down here. Stop it. Yeah, that's it. So it'll start it back up when it's finished. Okay. Right, let's make that once every second. 660. I suppose this would be better on VHF, probably. Well, not necessarily, unless you've got a lot of signals on. Alright, what's it doing now? Oh, it's finished. Yeah, it's muted it. So, if we go again. Oh, it's going to keep adding. Yeah, I need to issue a new command. It's going to keep adding to the list over and over again. Any new ones? I suppose it's alright, but I mean, I need to clear the list to start again. So I need to clear the list. I suppose we could scan 50 meters. 50 megahertz, I mean. Right. Okay. It got a bit noisy, didn't it? Got a bit noisy. Right, so that seems to work. So we could do with a notch to say how many it's found. We need to clear that list when it's finished. When it starts a new scan, it needs to make the list back to 0. Clear. So we clear the list when we start, and it needs to report so many found somehow. Where can you put it? It'd be nice if it added them to the display as it was finding them. So we could need a label here so we can do the counts. So where would it put it? I suppose we could put it to there. Alright, let's just find something. So you've got your S meter reading there. So if we put another one next to it. We'll call it station count. Station count. Found station count. Found station count label. The visibility. Oh, we'd have to go back a bit. Left. I need to go left 20. 10. How's that? No, not quite enough. Left 12. How's that? No. 11. Yeah. So the count will be 0. Default count will be 0. That's the wrong one. Count will be 0. Okay. So we go found station count. Oh, we want the visibility. Visibility hidden. Okay. Oh. Oh, so it's hidden to start with, so we want that there. So when we do a scan, right, here we go then. So we clear the count. We make the visibility of the grid, main window. Dot visibility equals system Windows visibility visible. Why doesn't it like that? Object reference required for a non-static field. Oh. Okay, we can do this somewhere else then. In the button. We'll put it in the button, the start button. Right, so get rid of that. Found grid visibility visible. And found station count label content equals 0. Right, and what's happened here? Why's my mouse died? Oh shit, my mouse has died a death. My mouse is gone. It needs charging. Damn it. Damn it. The mouse needs charging. So where's this other one going to? Camera. Where's that camera? I don't need the down camera. Let's just charge my mouse up. Done too much scrolling, it's died to death. Right, we're back on. Yeah, we're back on. So we've got we make it visible, set its label to that, and for some reason we've got to wonder why it wouldn't let me do that. Right, so when it counts it up, every time it adds one, it needs to update the add active stun. Yeah. Right, so we need to go in there and label. This won't find it. Main window, we'll have the same problem. Count is plus plus. It's not going to like it, is it? So it wants object reference is required for a non-static field, method or property. How do I make it an object reference? Right, it needs a something. Oh, I need to pass it in. Okay, so I can do that where I wanted to do it in the first place. Well, I've got to pass in the control from the start. Seek. Every time it adds one, like that, and it won't know what it is, so I've got to pass it in, serial port, start frequency, end frequency, and we want label. Right. Using system controls. Which controls? UI. No. Data. Controls. No. System what? I forget what it is. Alright, let's ask ChatGPT. Oh, this one. What is base class of label control? Content control, layout panel. No, UI element, framework. As in using system controls label. Namespace, that's it. An object control. Why isn't it not telling me what I want to know? System Windows controls, that's all I want to know. Puts it right at the end. I can't remember. System Windows controls. Okay. So we're going to add a label, that's right, and call it what do we call it here? Same as that. And this will be content equals right, so we want the active list count. So the active list count, that's all we want. Okay, so it should update the count as it's finding them with a bit of luck. Let's try it. Build errors. Right, what's the error? No argument gives. Oh yeah, I didn't pass in the. No, that's not the right one. That one. That's it. Okay, what time we got? 11:45. Right, we'll have to knock it on the head a bit. Right, let's see if this gives us a count. Certainly does. Certainly does. Do the little flash thing. That's actually found 16. Finished. Right, okay. Let's see what it can find. on the 14 megahertz. 14, 50, 14, 150 to 14, 380, 14, 380, that's it. Yeah, okay, and we'll look between the channels as well. 500 hertz, okay. Let's give that a go. This will be the last one. We'll pack it up in a minute for the night. Gotta go back to work tomorrow in the morning. Right, here we go. Yeah, it needs a little marker on the front to show it's going over the threshold. Right, it's got 252. So we need to raise the S. Raise the S meter. Let's say, I don't know, 8. Anything over 8. There's not much on 14. I only found 12. It's too late in the night. Okay, let's where should we change it to? I don't know. God knows. Should we search for something? Let's go lower. Let's go 150. Let's go there to let's say 1.4. There you go. Yeah, let's try that. Probably find some CW. You could change the mode from here and say I'm searching for CW. Pretty dead. It's found 18. Right, so that band's dead, so let's try a different band. 7. Right, okay. Oh, we got a lot of noise. Right, let's close that down then. Is it finished? I need to know which channel, which one we're on. So it could say, oh, that's enough for one night. Let's sort that out. Right, let's have a look. So let's just try something. Oh, we're still changing the frequency here. I have to wait till it stops. I've got to sort out stopping this as well. Oh, tired now. Yeah. Right, 4 hours, that'll do it. Christ. My aero's not the best for picking up 40 metres or 80. Right, let's just stop that now. Save it all. Not that. And close that down. Close that down. Close that one. And we're back on that one. So if I run it up one last time, where is it? There it is. There's the live one. Let's give it a go. Yeah, it's all a bit mad. Just experimental, seeing what we can do with it. Right, maybe we could deploy that to other radios as well. Yeah. Can't stop it, so I can if I close it. There we go. Right, anyway, that's gonna about do it for today. Thanks for watching. Catch you on the next one. Bye bye.
Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
Speech is still very complicated. Music is simpler. Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. The art of leadership is delegation.
That information is not available. This constitutes all available data.
You know what they say. No good deed goes unpunished.